Hi everyone, my name is Ching-Ya Chiu. Today I will introduce my paper, 360MVSNet, Deep Multi-View Stereo Network with 360 Images for Indoor Scene Reconstruction. This is a joint work with Yu-Ting, I-Chao, Shen, and Yu-Ting. Multi-view stereo is a text that aims to estimate the dense representation of a scene given multi-view images and calibrated cameras. While previous works have achieved promising performance, they tend to use normal field of view images and focus on object-centric scenes. When it comes to reconstructing large-scale scenes, the process of collecting input images becomes very labor-intensive since this work requires densely distributed captures with enough overlaps. Therefore, we propose to use 360 images as inputs for multi-view stereo since it can provide broader coverage of a scene in a single shot and requiring fewer shots and less effort on matching image pairs with enough overlap. Here is the architecture of our network. Our proposed 360 sweeping module warps the feature map of a source image onto a series of virtual spheres centered at the reference view with different radius based on the depth hypothesis. With carefully defined process, we can resample the source view feature to the reference view based on the depth hypothesis. By sweeping through different radius, source view features are warped to the reference view to form a cost volume. The cost volume is regularized using a 3D unit to form the probability volume. With the estimated probability volume, we can compute the per pixel degree of uncertainty and efficiently narrow down the depth interval and reduce the number of depth samples. The existing datasets for multi-view stereo mainly contains object-centric scenes with perspective images. To tackle this problem, we generate a large-scale synthetic dataset, EQMVS, of indoor scene images in equirectangular format. We leverage the texture, meshes, and physically based paste tracer to render the 360 images. Our dataset comprises 1,014 scenes. We compare our methods against both traditional geometry-based methods, CodeMap, OpenMVS, and learning-based method, MVSNet, over the EQMVS test set. In this experiment, we use input images captured at the same locations for all methods, meaning it takes similar efforts to collect the input data. Our method outperforms all the other methods in terms of completeness and overall score. Here is the qualitative results. Compared to the other methods, our method is less sensitive to the areas of visual overlapping regions due to its broad FOV and continuous information within a single 360 image. In contrast, other methods struggle to reconstruct the entire environment and often only recover a small region of a scene. We show the evaluation on number of cameras. To achieve similar completeness score, previous method requires 20 times input images than ours. In this figure, CodeMap and MVSNet use 300 perspective cameras with 70 field of view, while our method only used 25 360 images. We can see that our method boosted the reconstruction completeness while saving 12 times efforts. Here, we compare the results with real-world images. Our method uses only 11 360 images, while other methods use 66 images. As the figure shows, our method reconstructs the scene more completely, even with fewer images. To make a conclusion, we propose the first multi-view stereo deep network using 360 images as inputs for reconstructing 3D scene structure. Our 360 spherical sweeping module embeds the 360 camera information into the training process. To overcome the lack of dataset, we generate more than 50K images in equirectangular projection. Our method outperforms other methods in terms of completeness and overall score. For more details, please check out our paper. Thank you for listening.